This is my Harbor Freight lathe, and it needs a clutch. No, not that kind of clutch. That's for a car. I need a clutch for my lathe. Greetings, fellow DIYer, and welcome to my video. As I said, this is my Harbor Freight lathe. I've made all kinds of upgrades to it, but that is a different video. This video is about making a clutch for the lead screw. I've started a project called ELS, or Electronic Lead Screw, which allows you to do threading using a stepper motor to drive the lead screw. This lathe was never set up to cut threads, so there's no way to engage or disengage the lead screw from any sort of motor or outside force other than the hand crank. Connecting the lead screw to the motor will be fairly simple, but I needed a way to disconnect it at the flip of a lever so that I wasn't fighting with the motor when I wanted to do manual operations. So this is the end of my lead screw. As you can see, there's a cast iron bushing right here that is supporting the end of the lead screw, but also giving it something to spin on. There is about 3/8 of an inch of space there that could be utilized, because as it sits right now, there's nothing sticking out of the end of the bushing to allow me to attach to. In order to create a way to attach a stepper motor to this lead screw, I'm going to have to modify this bracket so that the end of the lead screw sticks out so I have something to attach to. So I searched online trying to find a simple clutch mechanism for a shaft. I looked on eBay, I looked on Amazon, I did a general Google search and couldn't really find anything. I expected there would be somebody out there that had made a YouTube video of something they put together and that I'd be able to, well, take their design, make it work for my application. Was not to be found. You would think that with other people doing projects similar to this, that there would be a specific lead screw clutch out there, but I couldn't find one. This is what I came up with. This is the bracket that replaces the bracket that was on my lathe. It's quite a bit skinnier, and then it has a bronze bushing put in it so that I can have a little less contact material. Because the other one was cast iron, you had almost 3/4 of an inch of support material so that you weren't wearing a spot into the end of the lead screw. Here, by using the bronze bushing, I am alleviating that. The next piece is my collar. This is a simple collar that has an ID, the same as the OD of the end of the lead screw, which turns out to be 15 millimeters. This is a 5/8 keyed shaft that I turned down to that 15 millimeter ID so it would fit into the sleeve that I made. And then this brass piece right here is a stop that also holds the key in place. If you look at the end of this shaft, and the end of this shaft, you'll see a hole. The reason I did that was so that I could take this needle bearing and put it inside so that it supports itself. Basically, it gives me a connection between the two pieces so that it's not trying to move all over the place. That needle bearing came out of a transmission. This is my other shaft going from the clutch mechanism, which we'll get to in a minute, to the pulley that will be driven by a stepper motor. And this is the bracket that goes on the outside of the lathe to hold it all together. It also has a bronze bushing inside, and then this is a collar that is a press fit that goes over the bushing to help hold it in place. This is my slider to engage and disengage the clutch. Right now it's kind of long. I'll probably end up cutting it off somewhere in this neighborhood and attaching something here that will be a lever to move it back and forth this way. But for now, it slides this way. And then this is my slider rod that is a guide for my clutch fork. Now this is the business end of the clutch. This is everything that I really needed to make it work. It's a piece of brass that's fairly hard brass. It originally started life as some sort of a pin. I picked it up at a garage sale as just something that I could machine. It's got a groove machined into it for the slider, and then it's got 2 keyways cut into it so that I can connect and disconnect the 2 shafts together, engaging and disengaging my lead screw. I opted to go with brass on this particular piece because it is a great low friction material and a great wear material. If I'd have made this out of steel, I probably would have needed a bushing or something in this groove to rub up against the fork. This is the replacement bracket that now moves closer in and actually comes right up to the threads on the lead screw. As you can see, it's quite a bit thinner than the piece that originally came with the lathe. Here we have the coupler installed on the end of the lead screw. If you notice, there's smaller set screws here, a small set screw here, and a larger set screw there. And you may be wondering, why did he do that? Is the bigger set screw better? Does it bind into the end of the lead screw better so you get a better connection? The answer is I screwed up. I drilled the hole too big and had to drill it one size bigger and go with the next size up set screw that I had. All right, the next piece going into the clutch mechanism is this bearing. Like I said, this just helps support this end of the shaft to the other end of the shaft. The clutch mechanism was also designed so that it helps support the 2 shafts together. If you look at this key, there's about a 1/4 inch difference between the end of it and the end of the key. And that is so the clutch piece, the brass piece that I'm referring to as the clutch, constantly rides on the very tip of this shaft, helping tie it all together. So this is the other end of the shaft. Like I said, that bearing goes inside that hole, and as you can see, there's that slight overlap that I was talking about, and then this is where the clutch mechanism can go from disengaged to engaged. There's nothing terribly fancy about this outside bracket. It's got 3 bolts holding it into the end of the lathe. Like I said, it's got a bushing in there and then a sleeve holding the bushing in place. And it gives all of this rock solid. I mean, it holds it in place. There's no play in any direction, which is really nice. Again, we have disengaged so that the lead screw can spin freely. And then you just put a little pressure and she locks up and goes on over. This is the clutch slider fork. Same technique as I used on the end. I have a bronze bushing going through, but since this is such a thin piece of steel, even though it's a press fit, it didn't really want to stay put. So I machined a sleeve to press over the outside and hold it all together. Fits right up into here, and then this slider rod goes in, adding some stability. This is the clutch for my lathe, all put together. It has super smooth action, super easy to engage and disengage. And with it in a disengaged position, as things are spinning around, I'll be able to just put a little pressure and slide it right in and go. So you may be wondering why this clutch is even necessary. There's controls for the electronic lead screw to feed forward, to feed backwards. So why would you ever want to have this clutch mechanism? Well, the simple answer is I don't want to do everything through the electronics. I like to machine stuff by hand. I like to crank the lead screw. And currently, even with no power to the stepper motor, if I crank the lead screw, you hear that sound? That's coming from the stepper motor. There's also a fair amount of resistance as I'm turning the lead screw. So over time, my arm's going to get tired. When I disengage it, It's a whole lot easier to turn, and it's a whole lot quieter. And that is why I need a clutch for my lathe. In the future, I'll be doing more videos on all the upgrades that I've done to this lathe. I've already got a video out there talking about how I converted it from a mill-lathe combo into a standalone lathe and a standalone mill. If you want more information on that project, see my video.
If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.